Sweet. Perfect time. All right, let's do it. Yeah, so jump back in. Make sure this is lined up all right. And turn to that second page, front of the second physical page there. So call it page 3 if you want. And take out a calculator so you can help me do some calculations real quick. Because what we're going to develop eventually, by the time we get down to it, is an equation for continuous compound interest. And so we're gonna like try to simplify things as much as we can, pick easy numbers, see if we can figure this thing out by looking at a very, very simple, specific, hopefully pretty easy kind of question. Okay. All right. So looking at the top there on the second physical page, front and back, so you know, call it page 3, whatever you want. It should say a closer look at continuous compound interest. Because if there's anything I want you to understand, it's how it actually works. And you can see that right there. Having been in finance for 3 years, I do have some nice background into how all this stuff really works. And I love talking about it so that you guys get it too. The reality of finance is that interest is either compounded monthly, daily, or just what's called continuously. Like it just never stops. There's no break between them calculating the interest and dropping into your account. And they just boom, 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 one right after the other. And so I want to see kind of what happens as we mess with one example. Yeah, that's one. As we mess with is it stuff weird? Yeah, try that. Thanks, sir. As we mess with one specific example. With a very, very easy choice for P and for R, and we're just gonna do it over 1 year, but we're gonna mess with N, and I want to see what happens. So I know there's a lot of spots there to write some things down, but let's do it together. We're gonna work through all of these together. Then by the time we get to number 7, we'll have this formula. Now, this is the last of the 3, so I even left a spot on this board here eventually for when we come up with it. But I want to see if we can do it together. Okay, so here's the thing. Super, super easy. P is just 1, okay? $1. Okay, we're going to start with easy round numbers to make it easier to come up with this formula. And the rate is 100%. That's what they're telling us here. So that's not even part of number 1 yet. I'm just giving you the lowdown, right? Consider an initial deposit of $1 with a rate of 100%. So if like 5% is 0.05 and 20% is 0.20, what's 100% as a number? Huh? That would be 1%. 100%. The number 1. Okay? 100% as a decimal is just 1.00, which is just 1. Yeah, so you're on the page. It says a closer look at continuous compound interest. And what we're going to see is how things change from one level to the next, to the next, to the next. Okay? So, eventually, things are going to change from daily to annually to monthly to daily to hourly, every minute, every second, and see what happens. But we're just going to do it for 1 year. Okay, so that's why I'm like jumping right to A of 1 for number 1. But just to make it a little bit easier, find a place somewhere else. I don't care where you put it, but just put it like kind of off, maybe off to the side there, like top right little section here, maybe. Let's just write an A of T so we've got it. P 1 plus R over N to the NC. So P is $1. Cool. Parentheses 1 plus Like the longer this year goes, the stranger people get. All right, R as a decimal was just 1.
Hey, Rosie, can you like adjust the camera because it's kind of a glare on the board?
Yes. I'll hold it up like that.
Awesome, thank you.
Okay, so A of t, 1 times 1 plus 1 over, and I'll try to say it out loud. We'll all be down soon. So we don't, like, we're going to mess with different ends, so I'm just going to leave it like that for right now to the nt. Okay. N will be a number. Really nice. Super bright. All right, cool. A of 1, when we're talking about compounding annually. Well, let me ask you this. 1 times whatever, does that 1 make a difference? So is it all right if I just drop that and I go like this, 1 plus, is that cool? It's gonna make it easier for us. One last thing to write down, 1 over, well, n. Compounded annually. What does annually mean? Per year, so like once per year. 1 over 1. 1 over 1, yeah, right? And it's just 1 when they say annual. And then, okay, so n1 times t, and again, we're just going to do 1. Okay, all of these, t is just going to be 1. My goodness, that's a lot of 1s everywhere. All right, so it ends up being like 1 plus, yeah, question?
Are we just supposed to be writing this in black? For number 1?
This is number 1, yep.
In black.
Yep. The stuff that's in red is just like I'm just writing down what they already told us. What's in black is going to be each one. So 1 plus 1 over 1. Okay, so 1 plus 1, right? And 1 plus 1 to the power of 1. What's 1 plus 1? Okay, so $2. So weird. I wonder why none of my pens have any ink in them.
Now you can see them in the cut.
I don't know, because they're not there yet. All right, so if we compound annually at 100%, we just double our money, right? $1 becomes 2. And so the question is, like, if I keep everything else the same, it's still 100%, we're just doing 1 year. If we start compounding more often, how big can we really get this money to grow to? Is it just going to keep getting bigger and bigger and bigger? All right, can I turn my $1 into $5 or $20 or $1,000? Like, how far can I go if the only thing that I change is this number, right, that n, right there, 1 plus 1 over, but nothing else changes. $1 starting amount, which is this 1 sitting right here that I'm not going to bother writing anymore. Rate of 100. Next one was what? Compounded monthly. So 1 plus 1 over 12. To the power of 12 times 1, right? Right? 12 times 1. But t is always 1, right? Okay. Is it all right if I just do this? Like just 12? Same thing, right? Okay, cool. Somebody help me out. 1 plus 1 over 12 to the 12.
This is still number 1, right?
This is number 2. So we did yearly, annually. Now we're doing monthly.
Wait, because I'm on. So next page is number 4.
No, not next page. This one. We're going to work our way down 1 through 7. We're going to do the exact same problem. We're just going to mess with n because you see we're going to start going faster and faster and faster. What do you get? 2.61? Okay. That's pretty big right away. $2.61. Is that right?
I got 5.
Oh, you put 21. I think that's right.
Yeah, that's good.
You guys get 261? Yeah. So just going from yearly to monthly, we made I know it's not a lot of money, but start with $1,000 or $1 million, right? We're talking a big, big difference there. $2.61 instead of 2. So we jumped up 61 cents like that. Okay. So none of this is going to change, right? The only thing that I'm going to do differently is mess with that. I want to see if I can just keep making more and more and more and more, and if this is going to keep growing and growing. All right. So what about compounded daily? Now, I could have gone weekly, but I skipped it. 365. So down here goes 365, and so does that. Again, it's times 1, right? Because it's 1 year, but I'm saving us the issue. That's probably a decimal. 1 plus a really, really small number, so it's like just a little bit more than 1, but 365 times. Pretty good. So we went up 61 cents the first time. I wonder if we go up like even more this time. I wonder if we're like 350 or something. 271? Did you get 271 also? That's it? Okay. So about 271. Yeah, we're rounding, so. The first one was exactly $2. That's why I was just equals. This is approximately equal to this. All right, so we went up 61 cents the first time. Just by changing 1 to a 12. But then we go from 12 to 365, and we only go up 10 cents. But at least we went up, so that's good. I feel like I can keep making some more money. All right, let's keep going. Again, 1 plus 1 over. The only thing that's going to change is that n right there. But it's not hourly per day. It's not how many hours there are in a day. It's how many hours there are in a year.
8,760.
How much?
8,760.
How'd you do that? 24 hours a day, 365 days a year, 8,000 what? One more time, Ash? 8760?
Yeah.
8760, 8760. Now we're getting super, super tiny, like barely more than 1, but we get to multiply that number by itself over 8,000. $2.72, right? Because 718. All right, so we're starting to get really, really small here. So I'm actually gonna write more decimals than we would normally round to. Give me like, hey, you got it out there. Give me like the 6 decimal places. 718.
1, 8, 1, 2, 6, 6, 9, 1, 6.
No, that's okay. That's plenty. That's pretty accurate. Ooh, okay. So we jumped up 61 cents, then 10 cents, then less than a penny. But this number grew like really, really, really quickly. And yeah, we're still getting bigger, but it is drastically slowing down how fast it's getting bigger, right? Right. So that was every hour.
I don't know if that's good.
Is that not right?
I didn't do anything.
Well, your number is on the bottom. 62. See if you get it though. I want to make sure we got the right numbers. I think that's right. It looks.
I still got.
Well, because you do 1 plus.
Oh.
Get rid of that 1 plus. It's just 1 times. All right. 1 plus 1 over. Now every second. Jackson's got it. Tell me, Jackson. Oh, minute? Is it minute next? Oh, my bad. Yeah, every minute first.
525,949. Okay.
Try it again. 365
Yeah,
times 24.
last series.
Well, Siri probably did it with 365.25 days because of the leap year. We're going to keep it simple and just go 365. So 365, number of days. That's more accurate though, but I was going to pick a number that maybe you guys might have recognized. Times 24 hours in a day, times 60 minutes in an hour. It tells me how many minutes there are.
600.
525,600 minutes.
I was about to say there's no way there's only 5. So that's how many minutes.
That's how many minutes there are in 1 year if we use 365. Jackson's, I think, is a little bit more accurate. But that's how many minutes there are in 1 year. 525,600. You guys ever heard that number before?
I would think that'd be way more.
What's that from? You
I don't know.
ever heard that? 525,600 minutes.
Sounds familiar.
525,000 moments. No? Rent. One of the best Broadway plays of all time. Or The Office. It's also in The Office. When they calculate how many minutes Michael Scott has worked at The Office before. So we went up 61 cents, then 10 cents, then less than a penny. I'm pretty sure it's probably not going to change too much. Here, read it to me. 2.7.
718275242.
Cool. I think that's the same number.
Holy.
We're still going up real fast, so we're really starting to slow down big time.
Slow down.
Right? What's happening is this number starts to level off. And as much as we want like exponential growth to really like grow without bound and just get bigger and bigger and bigger and bigger and bigger, what's happening, and we'll do one more, number of seconds, this is probably going to be a pretty big number because we're going to multiply by 60 again. You're going to see it's probably really, really close to that number.
So am I taking the 525?
So 525,600 times 60, because there's 60 seconds per minute.
31,536,000.
Oh my God. Exactly, 000.
Yep, yep.
315,36,000. So in 1 year, you experience over 31.5 million seconds. Kind of crazy to think about. Take a guess. What do you think the first 4 numbers are?
718.
Absolutely. 2.718.
I'm guessing it's gonna be 2.
Maybe another 2. 7.9. Like maybe it jumps up to an 8. Let's see. Somebody help us out. 2.7182. Could be still like 799 or something. 2.7182. I don't have 1 plus 1 over 31536,000 to the 2.7.
2.71828247.
31536,000. 31536,000. 31536,000. 31536,000. What's that? 2.71828. He goes 17785. 2.718282473. Like it would round at the end if it was going to round. It would just be the last decimal. Let's see. Let's see. Let's check our number first. Let's make sure that's good. So let's go. 365 times 24 times 60 times 60. 31536,000. Cool. 1 plus 1 over 31536,000. 31536,000. 2.7182817. Not sure why. We'll give it the same 8. I think I got the same one together. All right, so here's the thing, moral of the story. This thing doesn't just grow forever. Okay? And what's happening is we're actually looking. Guys, listen up. I know it's a funny Instagram page. We can look at it after class. Maybe we should put our masks where they need to be, and we wouldn't have to worry about pages like that, Sean. or Otman coming over the speaker telling us we need to wear a mask so we don't become non-invisible. Or Castle Blue or whoever. All right. Clearly, this thing starts to slow down really, really dramatically. And what's kind of crazy about this is that that number that we're getting close to is an actual number. Now, of course, our calculator is stopping, rounding, right? Dot, dot, dot. It's going to keep going. But there's an actual number. And here's what we're doing. Okay, so I don't care where you put this. Maybe just kind of off to the side. Don't put it for number 7 just yet. We'll get there. But what's happening is we're doing this. We're taking this, 1 plus 1 over n to the n. All right, that's what we're doing. And we're just changing n, right? But what are we doing to it? 1, 12, 365, 8,700, 52, you know, just keep getting bigger and bigger. Where is n going? Here's what we're doing, right? 1 plus 1 over n to the n. What are we doing to n? Getting bigger and bigger and bigger every time, right? And it keeps like way bigger. We can keep going, right? This was every second? We could do every tenth of a second, every millisecond, every nanosecond. We can keep going. What are we letting n do if it keeps getting bigger and bigger and bigger and bigger? What is n headed towards? We haven't had this conversation yet, so probably going to say something in here that you've never said. What number is n going to?
Infinity.
N is getting bigger and bigger and bigger and bigger and bigger. But the issue is that this number is not. It's starting to slow down. Okay? This number is converging. Okay? This series of numbers, I'm getting like 3 years ahead in math, but that's kind of cool. We're doing what's called an infinite series. We're looking at a sequence of numbers, an infinite sequence. Series is when we add them all up. This is an infinite sequence of numbers. But it's converging. It's not growing and growing and growing. It's starting to slow down. And what's happening is we are actually approaching a number. This is a number you've never heard of. You want to know why? Because this is where this number comes from. Okay? And here's another reason why you've never heard of this number. It's because when I write what's on the right side of that equal sign, you're not going to see a number. You're going to see a letter. But it's a number. Just like pi it's a Greek letter, but we use it for a number. Same thing here. I'm going to use a letter to represent the number that we're getting closer and closer to. And that number is the number E. The number E.
Not the letter.
Correct. Okay. This was discovered by a mathematician named Euler. Weird, right? I know it looks like Euler, but it's actually pronounced like Euler. Yeah. Okay. We're actually approaching what's called Euler's number. Okay. And he didn't name it after himself. Like, oh, my name ends in it. It starts with me. Let me just call it E. That's a misconception. It's actually something that, like, he had used A, B, C, and D for something. So he was like, oh, the next number I got is E. And it comes from this. Okay. And the thing about what we've got right here, okay, with E, is it's actually part of this compound interest formula when we let it keep getting bigger and bigger. Like we're going to just keep letting it grow and grow and grow and grow. Okay. And so what I want to try to do is use that number to get rid of some of this stuff over here to come up with a formula that like lets us do this. Like let n go to infinity. Now, infinity is not a number, right? It's a direction, right? I can keep getting bigger. Like I can go on the number line this way forever. That's really what I'm doing. Okay. And I'm trying to see what happens as I do that. And what we do is we start getting closer and closer to this number right there. And what I'm going to do with our last, see if I can do it, 45, 25. The last 12 minutes is change the compound interest formula to become a continuous one. Now, you don't have to know how to prove this the way that I'm about to. What you just have to know is where to find E on your calculator so you can type it in. Okay? Take a look on your calculator. Do you know where pi is? Let me try. Let's start with that one. Where is it, Ethan?
It's over the.
Yeah, oh, like to get into the exponent, that like up-looking arrow is pi. So second exponent. Look at the button right below that. There it is. Okay. So do this. Clear out your calculator. Okay. Do second division. If you need to, press enter. Second division sign. Press enter if you have to. Yeah, that'll be. Okay. 2.7, 1828, 1828. Mine stops at 46. Actually, like 45, 90, 45, blah, blah, blah. It goes on forever. Okay. 2.7, 1828, 1828. So we actually got pretty close. 2.7, 1828, 18. Yeah, we got pretty close. We were 1, 2, 3, 4, 5, 6 correct decimals. It's crazy. Super, super accurate. Now, so there's E. When we come up with the formula, we're going to use that as a number. It's going to have E in it. But so I wanted to prove that as to where this formula comes from, just to kind of, on a Friday afternoon after lunch, melt your brains a little bit. Do not write this down unless you really feel it. I would rather you see if you can make sense of what I'm going to try to do in these last 8 minutes, and then we're going to have a formula, and we'll be done. On Monday, we'll actually try. We'll do some compound interest. But it's so cool that we can do this crazy. We can go to infinity, but end up with a number. And there's a lot of really interesting things that start happening when sequences converge like that. Sure. Okay, here's what I'm going to do. I'm going to start with the compound interest formula. All right, P, I'm just going to do the whole right side. R over N to the N. Okay, now, you don't have to write this unless you want to. It's hard enough to follow and just watch. It's a write it too, so it's up to you. Now, I'm going to do something to help me out. And this was not my idea. Okay, this was decided a long, long time ago, so I'm stealing this proof from somebody else. This N and R fraction right here, this R over N, I'm going to mess with it. But I want to do it in a way that's easier for me. So I'm going to bring a letter in there just temporarily. Okay, so I'm going to let M, I'm just making it up, I'm just taking a letter I haven't used yet, be the reciprocal of that. Okay, I'm just picking that to help me out. Okay, because if that's true, look what happens. If I flip this fraction, look what I get. I flip the version of that one, and I'm going to use this instead. Instead of using 2 letters, I'm just going to use 1. Okay, so check this out. 1 plus 1 over N. Cool. I'm just making it up. Okay, I chose to do that to help me prove what I'm doing. All right, so I said, okay, I'm going to let M be the reciprocal of this, so I have 1 over M be actually what was in it. But if that's true, watch this. All right, because look what's in the exponent, nt, right? Well, this isn't in terms of n yet. I'm going to cross multiply. Thing we can do, right? N times 1, M times R. What order do I want to do this in? Hold on. I don't think it really matters. M times R times M is the same thing, right? Watch this. Yeah, sure. I'll do it that way. N is now M times R times 2. All right, so I named M what I felt like doing. Okay, I'm cheating my way to this proof because I'm just making it up. It's not really cheating. I'm just picking something I know is going to give me what I want, and then I can reorder. Look what I've done. I've just let N go away. Right, N is gone. And I've kind of replaced it with M in a way, right? 1 plus 1 over, wasn't it 1 over N that we were messing with? Now it's just 1 over M. Okay, check this out. Watch this. What's the shortcut when I have exponents raised to higher exponents? What do I do with those?
No.
Multiplication, right? So isn't this the same as that? Okay, cool. Now, let m go to infinity. And I'm melting your brains, right? Let m go to infinity. 1 plus 1 over m to the m. Well, all right, 1 plus 1 over n to the n. Here's what letter I choose. As n went to infinity, what did we get? What was it? The number e. All of this in here, if m goes to infinity, here's what letter it is. E. Principal, rate, and time. That's all I need. Because continuous compound interest, n is not a number anymore. N is going to infinity. I'm going to do it, not every minute, not every second, not every nanosecond. I'm going to do it continuously. I'm going to compound so fast, you cannot count how many times I've done it. The continuous compound interest formula is P times the number E to the power of RT. Now, if it helps, put a little multiplication dot between the P and the E. E is what's being raised to that RT power. P is just P time. Okay? Principal. That's all I have to do, remember it. Okay? This is the number E. Okay, which is approximately 2.71828 45 90 45 blah 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 blah. I think it's going. Just like pi, 3.1415926535897932384626 blah 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 blah. 7th grade, my math teacher had the digits of pi across the top of the ceiling, so I sat down and memorized it. It was like 7th grade math. I guess I was destined to be a math teacher. That's your continuous compound. And it comes from all that craziness that came down to this. 1 plus 1 over n to the n, whatever, 1 plus 1 over m to the m. Here's a letter I decided to use, right? When I told you all the number of times things compound, I just called it n, right? I just made that up. It didn't have to be n, I could call it m, I could call it whatever I want. And as kind of tricky as that is, I only had to do this. Let m be a number. Okay? And that's the formula that we will use on Monday to wrap up everything that has to do with interest, percent growth and decay, all that stuff done on Monday. And remember, Monday is a regular school day. I know, right? That's the tip of the iceberg. That's the tip. It's there's actually like 3 ways that I can prove to you what E is. What's up?
I'm not sure.
Huh? You don't have to remember any of that, but could you like sort of follow it a little bit? It's all I need from you is this. That's what I need. The number E comes from somewhere. That was one of those places. Yeah, it's actually being charged right now, so leave it like close to it, and I'll plug it in when that one turns before I leave today. There you go. I'm good. We got 2 minutes. Hang out. Woo! That was a good one. I will see you guys tomorrow at home. Thanks for being here. Or not tomorrow.